We're going to do some two-way tables as well, which will help us to determine if something is mutually exclusive. And we're going to learn the general addition rule. All right, students in a college statistics class wanted to find out how common it is for young adults to have their ears pierced. They recorded data on two things, gender and whether or not the student had a pierced ear. All right, for all 178 people. So here we have male, female, total, and then we have pierced ears, yes or no. All right. Suppose we choose a student from the class at random. Define event A as getting a male student and event B as getting a student with a pierced ear. What is the probability of event B? Just anyone with a pierced ear. Raise your hand if you can tell me what that would be. Alex? 103 over, I agree with you, 178. So this would just be the total, right? So I have 103 kids with pierced ears over 178 total people. All right, find the probability of A and B. All right, this would be the probability of A, which is male, and B, which is a student with a pierced ear. Male and pierced ear at the same time. And means occurring at the same time. Raise your hand if you can tell me what you think that fraction is. Clinton, what do you think? 19 over, what'd you say? Yes. Okay, 19 over 178. So this is out of everyone, there are 19 males with pierced ears. Okay, so that would be the probability of getting both male and pierced ears at the same time out of everyone. All right, interpret this value is both males with pierced ears, okay? Now I want to do the probability of A or B, okay? This means male plus they have pierced ears, right? Remember, or means add. All right, so we have male first. Okay, first we're going to add up everyone who is male. Okay, how many males are there in this study? 90 out of 178. Okay, the probability of just getting male, if you were drawing all their names, okay, would be 90 out of 178. Now, I'm going to add the probability of pierced ears. Okay, how many people have pierced ears? Oh, yeah, thanks. Go back up there. Okay, 103 people have pierced ears. Now, if I just added that together, my answer would be wrong. Who did I double count? Yeah, the males with pierced ears, right? So I have 90 males. I have 103 people with pierced ears, but I double counted these 19 people. I counted them in both groups. Do you guys agree? All right. So you have to subtract out whoever you double counted. This formula is called the general addition rule. I would write down this one and then fill in the words that those symbols mean above it. Okay, this sheet or this formula is provided. You definitely need to use it, know it. All right, so this little union symbol means or, okay? Okay, union. So the probability of A union B does mean or, which is the probability of A plus the probability of B minus the probability of A and B. Sometimes you'll see that this symbol means like intersect. I think you use it in like pre-calc and stuff too. Don't we do that in pre-calc? Yeah. All right, in stats, it means and or like occurring at the same time, right? Now, if two events are mutually exclusive, we learned this the other day. If events are mutually exclusive, the probability of A and B is 0. There's no overlap, right? If events are mutually exclusive, you can just add these together. But in our last problem, Was male and pierced ears mutually exclusive? No. All right, there were males with pierced ears, okay? So it's not mutually exclusive. So you had to subtract the overlap. Otherwise, you double counted it. Okay. A survey of all residents in a large apartment complex reveals that 68% use Facebook, 28% use Instagram, and 25% do both. Suppose we select a resident at random. What's the probability that the person uses Facebook or Instagram? So you would do this lovely formula. Probability of Facebook or Instagram. And you would do the formula is, well, that's the probability of all the Facebook users plus the probability of all the Instagram users minus the probability of both occurring at the same time. And I would plug in, that would be 68% plus 28% minus the 25% who do both. And I would calculate that, okay? Yeah, thank you. 71. All right, a standard deck of playing cards with jokers removed consists of 52 cards. So we reviewed our decks of cards. All right, it's coming back up yesterday. 13 suits. They go an ace through a king. And we do have what are called face cards. Those are jacks, queens, and kings. Okay, those are face cards. Imagine that we shuffle the deck thoroughly and deal one card. Let's define events F as getting a face card and H as getting a heart. Make a two-way table describing this sample space. All right, we have to be able to make a table, and this is actually kind of tricky. I want you guys to try this in your notes, okay? So on another piece of paper, we are going to make a two-way table for this occurring. It's kind of like the ratio boxes a long time ago. All right, so we've got face cards and not face cards and total. So event F was face cards. So that means that the cards are either face cards, not face cards, or total. Okay, the second event that they were talking about was hearts. All right, so our deck of cards is either hearts or not hearts or total. And now we just try to fill this in. It's kind of tricky, but we're going to see if we can fill in whatever we can. Let's start with some totals, okay? How many total hearts are in a deck of cards? 13, okay? And there are 52 total cards. So how many are not hearts? 39, because there are 3 other suits with 13 each. Now I've got face cards and not face cards. Okay, let's do like how many hearts are face cards. This has to be a heart and a face card at the same time. Yes, this number is 3, right? So there's a jack of hearts, a queen of hearts, and a king of hearts. There are 3 that are both face cards and hearts. Okay. And now I can easily fill in this little part right here. So this tells me there's 13 hearts, 3 are face cards. How many are not face cards? 10. Okay. Okay. Now let's see if we can do total face cards in the deck, right? If there's 3 in one suit, how many total face cards are there in the whole deck? 12. I agree with you. Okay. Now I have 3 face cards that are hearts. And now I need the rest of the face cards here that are not hearts. What would go here? 9. And that has to like add across, right? And right here, even if I don't know what this means, I know it has to add down. All right, this would be 30. But I can also look at this. These are the not hearts, not face cards. And again, this has to add either direction here to give me 40. Okay. Okay, we made our table. That was challenging, but we did it. Find the probability of F and H. All right, so this is the next part. The probability of being a face card and a heart. And I'm using this symbol to help you learn what that means, okay? So this is occurring at the same time. What do you guys think? Good job. It's out of the total, the 52, okay? There are 3 cards that are both at the same time. Okay, 3 out of 52. Explain why the probability of a face card or a heart, how come you can't just add these like we did yesterday, right? Why am I allowed to just not be like, oh, let's add all the face cards and all the hearts? Because we have some we're double counting, okay? The 3 that are both, okay? So if I add, and let's just look at it. Let's start the general addition rule. It'll make more sense when I set this up, okay? So I have the probability of face card or heart, which is the probability of face card plus the probability of heart. And we are going to subtract, but let's talk about why in a minute. I'm going to follow the formula, okay? But let's look at it. So for probability of face card, what would you guys say? How many face cards are in the deck? 12 out of 52. All right, so I would put 12 out of 52, right? There's a jack, queen, and a king in each suit. Plus, now I have how many hearts in the deck? Yeah, I have 13 out of 52. The problem is I just double counted the face cards that are hearts because these events are not mutually exclusive, okay? They can occur at the same time, which means we have to subtract the overlap, which is the part we just did right here. There are 3 cards that are both. And that would give me an answer then. Oh, wait, I can't do math. That would be 16. Holy cow, 15. What is that? 12? 12? Heart, 22. Wow, it's a rough day. Okay. I'm tired. I'm like Miles over there. I just need a nap, okay? 11 out of 26. Every day, I know. Okay. So you could reduce or don't reduce 22 out of 50. All right, that's all good. So we add and subtract right there. Tough stuff. Okay, we're done. There is a worksheet. There's a worksheet. Yeah.